Okay, let me share my screen. Share entire screen. Able to see my screen?
Yeah. Yes, sir.
Okay. So probes. We'll discuss about the probes. Okay. So we use the terminology, the concept called probes in Kubernetes. Okay. So in Kubernetes, probes are used to check the health, the pod of an health, or whether the container is running or the node is up and running. So where we check using the probes only. Okay, so that is the reason we do configure probes in the manifest itself. Okay, so which is handled by kubelet. Okay, so kubelet is basically where we use as the component of node, so which monitors the probes via the kubelet to determine whether the container is running properly and whether it is ready to serve the traffic. Okay, and whether it should be restart or not. Okay, so that is done by probes and that is handled by kubelet. Okay, so I'll give the definition this way. So you guys are able to see my screen, right?
Yes.
Okay. So Niharika.
Yes, sir.
Niharika, am I audible?
Yes, sir.
I told to join at 7, right?
Sir, actually, there's a problem with system, so I try to
You
restart
should
it.
inform in the group at least, right?
I'm extremely sorry.
Okay. So let's go on mute. Let's continue our session then. So basically, I was saying probes in Kubernetes. So I'll give a statement. So in Kubernetes, probes are used to check checks the health checks the health used by the kubelet. Okay, used by the kubelet to determine. Okay, so to determine, let's give the points here. To determine the first point, whether the container is running properly, whether the container running properly. So basically we use container properly. Okay, and we use the container inside the pod, so that checks the health of a pod, of a container. Inside the pod, it checks the health of a container which is running or not, which is handled by probes. That is, I mean, that is managed by kubelet. Okay, the second point, so whether it is ready to serve a traffic. Okay, so it will identify whether it is ready to serve the traffic. Okay, and the third point, so whether it should be restarted or not. Okay, whether it should be restarted or not. So everything is handled by probes this way. So it is handled by kubelet. Via the kubelet, the probes will work and it will identify whether the container is running properly, whether it is ready to serve the traffic, and whether it should be restarted or not. So everything which is managed, monitored by probes. Okay, and there are two types of probes in Kubernetes. Okay, so there are two types of probes in Kubernetes. Okay, so the very first liveness probe. Okay, and the second one readiness probe. Readiness probe. Okay, so we do configure these two in the Kubernetes configuration or in the YAML to have monitored our container. We are checking whether it is able to serve the traffic or it should be restarted or not. And if the container is deleted, it will automatically create and restarts by from our deployment. Okay, so everything is monitored to check the health via the probes, which is managed by kubelet. Okay, now let's learn the liveness probe. So what this does and what is the significance of liveness probe in Kubernetes. Okay, so this liveness probe is basically, see, this purpose of liveness probe is used to check the container is alive. Okay, basically it will, the very initial point of liveness probe is used to check the container is alive. Okay, your container may delete at any time when there is a more load. If the container is withstanding, say suppose if your container is capable to handle 2 GB of data, if your data is increased more than 2, your container may crash, right? That time we should immediately identify the checks to be configured whether the container is not alive, means the container is stuck, or maybe you will get an error when you deployed image crash loop backoff, correct? So you might face this issue in the Docker. So that is managed by liveness probe. Okay. So the liveness probe is basically, the purpose of liveness probe is used to check the container is alive or stuck or crashed. Okay, if it fails, Kubernetes kills the container and restarts it through this liveness probe. Okay, and this is how we use the liveness probe. Okay, and also it uses to detect the deadlocks of unresponsive containers. Say suppose if you are having multiple containers in your platform, right? So it will also identify unresponsive containers. So if the container is not responding for your particular task, it will also identify the unresponsive container in the sense your uh, dongle images, right? So that we can identify by liveness probe. You guys are with me?
Yes, Sandeep.
Okay, so I'll give a statement for liveness probe. Okay, the purpose of liveness probe is used to check if the container is alive. If the container is alive, I'll give it in a bracket this way. So if not stuck or crashed, if the container is stuck or the image is crashed, if it fails, okay, so if it fails, Kubernetes kills the container and restarts it. Kills the container and restarts it. Okay, and also, so it will help to identify. So it will help to identify the unresponsive containers. Okay, so liveness probe is basically, okay, I'll give this way. And okay, so the purpose of liveness probe is used to check if the container is alive. Okay, if the container is alive or container is stuck or crashed, it will identify. Okay, so if it fails, Kubernetes kills the container, restarts it. So okay, if the container is stuck or if the container is crashed, okay, it will identify and it kills that crashed container or stuck container, and it will restart immediately. Okay, so it will help to identify the unresponsive containers. Okay, so we do also have the technical, so we should also have the uh, uh, technical manifest that we gonna use in our manifest to configure the liveness probe. Okay, so I'll give an example here. So how do we configure this liveness probe? Okay, so with the very first line we're gonna write is liveness probe. Okay, so liveness probe colon followed by the the gateway or the protocol http get. Okay, colon and the path after two space, we're going to define path slash, so which path, so where we have our application says whatsapp slash health, so it picks that path and checks the health. Okay, so here we define the path of health. Okay, and the port that we're going to define here, I'll explain this, 8080, and also the initial delay second. Okay, so here, so I'm gonna write here is initial delay seconds. I'll explain what it is. Let's keep it 5. Initial delay second, and the period seconds I'll keep it as 10. I'll keep it to 10. Okay, so this is a simple configuration to configure the liveness probe in our manifest. Okay, so what this defines, so as soon as we return this liveness probe, it will create a liveness probe in our Kubernetes component or in our Kubernetes network. It fetches the protocol http get, we need to point here, and the path of where it should check the health. Okay, so in our website that we implemented, one of the path called slash health. So say like when you configured your application called www.whatsapp.com slash chats slash health, so when you hit that URL, you will see the health of an application. So this liveness probe, it will go to that subpath under the health, it picks that data and monitors the container inside the manifest that we configured. You getting my point? That's why we define the paths here and the port of 8080. Okay, so why? Because we are exposing it here http get. Okay, and initial delay seconds. So basically this is the timer that we gonna give it to the container or the web URL to refresh the page. Initial delay seconds will keep it to 5. Within 5 seconds, it should get refreshed. Everything, it identifies the probe and it recreates the container, and it will help to identify the unresponsive container. Everything is done by within a 5 second. It is happening and it should happen. That's why we define initial delay seconds. Okay, and the complete to period seconds within 10, it identifies the probe apart from initial delay second, we do also define period seconds to, if there are any containers are handling more data, so might be we'll see it's a kind of break. Okay, that's how we use the period seconds. Within 10 seconds everything should happen. So that's how we configure this leanness probe. You getting my point? You guys are with me?
Yes, Sandeep.
Okay, so called leanness probe. So this we configured in our manifest in the configuration, in our configuration file.
Sir,
Similarly, we do
sir, can you please repeat initial day second 1 second, sir?
initial delay seconds. See, initial
Yes.
delay seconds is basically, see, what we do here in leanness probe. Leanness probe is helps to identify if the container is alive, right? So if the container is alive, it kills the container. If the container is dead, right, it kills the container and creates and restarts it as a fresh container. Okay,
Yes, yes,
and
okay. Yeah,
also
I understood about that.
that's what I'm saying. For this initial delay second only, we'll have to understand liveness probe will help if the container is crashed. It creates the new and restarts it, and it also helps to identify the unresponsive container. This is done within 5 minutes with the initial delay seconds of 5.
Okay.
Getting my point?
Okay.
So this complete liveness probe that we define initial delay seconds within 10 to 5 minutes. Sorry, 10 to 5 seconds.
Okay,
So
sir.
that's how the liveness probe will work. Clear?
Okay, sir.
Similarly, we do have the readiness probe. Second point, readiness probe. Okay, so similarly, kind of probe, which is readiness probe. So this will also use to check. See, the purpose of readiness probe is used to receive the traffic into the container, into the pod. Okay, so if it fails, okay, the pod is removed from the service endpoints, so it won't get any traffic. Okay, so basically the purpose of readiness probe is used to check if the app is ready to receive the traffic. Okay, so when we configured a readiness in our application, so it is ready to receive the traffic inside our application. Say like when you containerize your Jenkins. So when we configure the readiness probe, that application, your Jenkins application is ready to receive the traffic. The readiness probe means it is ready to receive the traffic. So that's how we do configure the readiness probe. Okay, so if it fails, okay, the pod is removed from the service endpoints. So we do also have the service endpoints. So it won't get traffic. uh, Guys, just a minute. Yeah, just a minute, guys, I'll be back in a minute. Sorry. So we were talking about the readiness probe. So the readiness probe is basically it helps to receive the traffic inside our application. Okay, if it fails, the pod is removed from the service endpoints. Okay, so we do have the service endpoints here. So where is the service manifest here? So here we do expose our application via the uh, service type as node port and the cluster IP. We do also have, see, you were able to understand this endpoint. Endpoint is basically the end point of our application. See, suppose when you configure your, okay, we can see this in the external name, right? So where is this external name? See here, say suppose if you have the URL of idc.jenkins.com slash some db, let's say /db. This is your endpoint. Okay, through this this complete web, the complete URL will be having handled by probes to monitor the health checks. Okay, so each of the path will be handled by particular pods to pick the data for a responsive of each and every component in the Kubernetes environment. So if the endpoint, if it the pod is fail to pick the data, so the readiness probe will help to get the data from the endpoint. Okay, so called, we do identify, it identifies immediately and it gives the data. The readiness means this endpoint is not ready to receive the data, the traffic into the data. Sorry, the traffic into the application. Okay, so it should get the data or the traffic to respond something, right? So called the readiness means the name itself is saying ready. So if the pod is ready, it will be responsive of receive the traffic, correct, right? So called the readiness probe. So I'll give the statement here. Okay, so the purpose of readiness probe, the purpose of readiness probe help helps to check if the app is ready to receive the traffic. We'll go this way. Is ready to receive the traffic. Okay, if it fails, the pod is removed from the service endpoints. The pod is removed from the service endpoints. Okay, so if that deletes, so it won't get any traffic. Get any traffic. So called the readiness probe. So basically, readiness probe, when we configure the readiness probe, it creates the readiness of the pod, where if if your container crashed, or if your container's image crash loop back off, your pod will not be ready to receive the traffic. That's it. Okay, so you take it this way. Readiness probe is the environment in Kubernetes which helps to check if the app is ready to receive the traffic. Okay, if the app is not ready to receive the traffic, might be the issue with the container is crashed, or our application is down. That's it. So we can identify when we configure this readiness probe. Okay, so here also we do have the configuration of the readiness probe. Similarly, we do have the, instead of liveness probe, we do also have the, instead of liveness, I'm gonna write here is readiness probe. Okay, so P should be in capital, and here also P should be in capital. So liveness probe and the readiness probe. So basically it checks the health. Instead of health, I'm gonna define here as ready. Okay, so it prepares the pod to receive the traffic. So if the pod is ready only, it helps to receive the traffic. So this will identify by readiness probe. You able to understand this? So we do have the configuration of readiness probe, and then the protocol that we used, HTTP GET. The path, instead of else, it checks the ready. If the pod is ready, or if our application is ready to receive the traffic, then only it identifies, okay, the pod is cleared to receive the traffic. Okay, clear with this liveness and readiness probe?
Yes, sir.
Okay, so if you have any questions, you can ask me. Anybody has any questions on the liveness and readiness probe? See, this is the only configuration that we configure this liveness and readiness probe. So basically both we use to monitor our container, our pod, our application is ready to receive the traffic by combining liveness and readiness probe, the function of probes in Kubernetes. Okay, and also no need to worry about the templates that we are writing here. The templates are readily available in Kubernetes document. Okay, so based on your requirement, you need to configure. Say suppose if you want, instead of this health, you might point in your customized point path, okay, to get your liveness probe activated. Similarly for readiness probe. Okay, clear with this? Let's give the path here. See, you should be very careful when you're writing AML in Kubernetes. There should be a two space when you start writing a next line, and here also two space, and these two are same, path and the port, and then initial delay seconds and the period seconds. That you need to you need to be very careful that when you're writing a next line, there should be a two space. Okay, clear with this? Probes, guys, are you sleeping or?
Yes, sir.
Okay, now yes, now let's move to the next concept called helm. Okay, so helm is basically, okay, so this is the installation instruction to install the helm. Okay, we will install it now and we'll see what it contains and what all the uh, component that we have in helm. Okay, so the helm is basically the package manager for Kubernetes. So when we are talking about the package manager, okay, so it is the complete package of helm is a complete package manager of Kubernetes. So where we can create a pods, create a deployments, create a services, create an ingress through a single deployment by deploying an helm. Okay, so till now we were having separate AML configuration of pod, right? Separate AML configuration of deployment and separate AML configuration of services, right? Here, and separate YAML configuration of ingress, correct? So we should have the 4 files or 4 to 5 files to be created for pod.yml, deployment.yml, ingress.yml, or or service.yml, right? So this through this helm, we can achieve all 4 to 5 services from Kubernetes through a single deployment called package manager. That is helm. Okay, you are able to understand this statement? So helm is basically package manager for Kubernetes, and using this helm we can create pods, deployment, services, and ingress. Okay, so I'll give a statement here. So helm is an package manager for Kubernetes by using helm, sorry, by using helm we can create pods, deployments, services, and ingress. Okay, so basically, so helm is a package manager. It's a complete package of pod creation, deployment creation, and we can also create services all for cluster AP, node port, external name, and the load balancer, and an ingress. We can achieve all these components through helm. Not only this, whatever we do have liveness and readiness probes, and every configuration we can also create namespace via the helm. There are a lot of components that we discussed, right, till today, that all the component we can create it through the single chart or a single deployment called helm. You were able to understand this?
Yes, sir.
Okay, now so this is the statement for helm. Let's say, how do we install this and what do we have it in the helm charts? Okay, so what I'll do, I'll just try to install the helm instances, and after the installation I also have the repository for the helm charts from GitHub. I will show what that data contains, and you can also create the helm in your own, which you have the code. Okay, so I'm gonna start an instance. So this is basically through this helm, we no need to write the simple, the required pod.yml or deployment or service or ingress.yml. You can achieve all the services, the complete Kubernetes package through the helm charts. We call it as helm charts. Okay, so copy IP, you go here, Ubuntu, because in your pipeline we configure only helm. Okay, we will not have the separate pod, separate deployment, service ingress and all. We do configure helm in the pipeline. In our CI/CD pipelines, we do almost all the component we use helm charts. Okay, so now I logged into the server. Let's go to change settings, appearance change. Let's keep it 18. Apply. Okay, now I'll clear the screen. So Kubernetes uses the Docker platform, right? So before moving to Kubernetes component or to the cluster, we should check the Docker status, correct? Sudo service Docker status, right? Yes, it is running, correct? Similarly, we do also have the Docker installed and it is running. Okay, as soon as we logged in, we Docker container, the Docker daemon will restart immediately. Okay, so now we should configure our Kubernetes cluster, which is our Minikube, correct? So where is our Minikube? Minikube is here. Yes, here. Let's start this Minikube. Okay, Control C. Okay, it is downloaded, and let's install this Minikube. Okay, now I'm gonna run this. Okay, so I have ran this install command, and let's start the cluster, Minikube cluster. Okay, clear. Let's start Minikube start. Okay, now it has started. So once this creates the container, we will install the helm, and we also check the helm version. Okay, now our cluster is set up. To set an alias, I'm gonna run this. So this is only in the minikube. Okay, don't run this command in all the cluster. So instead of pointing minikube always, I'm going to set instead of minikube as kubectl, because kubectl is the command line interface in Kubernetes where we use all our Kubernetes commands. Okay, so now I'm gonna run kubectl get pods. Okay, there are no pods. Currently, we are in the default namespace, correct? The context that we had in default, right? Similarly, I'm gonna run kubectl get ns namespace. Remember that we do have created a namespace called dev. Okay, so we'll switch to the dev. We'll set the context in a dev, because we should, whatever the resources that you create, we will be having the dedicated namespaces in our Kubernetes environment. Okay, we will not use any default namespaces in the Kubernetes. Okay, let's set the context. How do we switch a context? So here, right, through this command kubectl config set context current with a namespace to dev. Okay, now the context minikube modified, right? Now if you run this mini 5 with the grepping a namespace, you will see this dev namespace. Correct, right? So currently we are in the dev namespace. So before we are in default namespace. Correct. Now here we will install our helm. Okay, so here is the command to install. So basically I'm gonna download the repo of helm from the helm community with git helm.sh. Okay, so I'm gonna do curl to this from the GitHub. Okay, so I'm just downloading a file, that's it. I'm gonna run this curl followed by the URL. Okay, now if I do ls, you will get a script called get helm.sh. So you will get the script. Okay, so it is basically the bash script, so where we use to install the helm. Okay, so helm is configured in the bash script, so which helps to install the helm. Okay, now after installing, I'm gonna providing permission to run the script chmod 777, and after giving the permission just to run the script, that's it. So it will get installed, the helm will get installed in your platform. Okay, let's see. Okay, the helm version 3.18.4 is already installed. Okay, so I have installed it yesterday, so it is showing already installed. Okay, this is what I wanted to show you. I have installed it yesterday, the version with 3.18.4. Okay, so now how do we check the version of helm? We do also have, see, all of all the commands we use helm, the command called helm. Okay, so how do we check the version? We use helm version. Okay, so we have the helm version of version 3.18.4. okay, the build version 18, and the particular commit that is used is this, and git the go version. Go means the Kubernetes built with a language called Go. Anybody aware of this?
Yes, Sandeep.
Okay, so the complete Kubernetes infrastructure built with a language called Go. Okay, that version, which is the Go version, is 1.24.4. Okay, so this is where you see your this input from this command. You are ready with an helm configuration. Okay, so I'll give the command here, helm, to check the helm version. Okay, now how do we create it? How do we have this handle this helm? How do we create all our pods, namespaces, and deployment services and all? Okay, so if I do ls, this is the script of the helm. Okay, so what I'll do, how do we create an helm? So there is a command to create an helm called helm create. This creates our helm chart. Okay, so what I'll do, I'll create a helm chart of dev. Okay, so here is the command to create our helm chart called dev. Instead of dev, you can also point your specific environments if you are in the project. Okay, currently I'm going to use helm create dev. Okay, now creating, it is showing creating dev means it creates a folder. Inside that folder it will be having our the nested templates. Okay, let's see what it created. See, before, was it dev created? No, right? So dev is the helm chart now of the existing environment. Okay, let's do cd to dev. It creates in terms of folder only. So as soon as you run this command, until you install your helm command will not work. Okay, to make use of those helm charts, you need to install the helm by from these instructions, and you can create a helm using helm create dev. Instead of dev, you can also point. So what I'll do, I'll create one more helm chart of prod. Okay, so it will create a folder called prod. So let's see what is inside the prod. Okay, let's go cd to prod. Okay, so if I do ls, you will see complete the folder structure. Okay, so values.yml, chart.yml, and also there are two files under two folder, which is templates and the charts. Okay, so what are these four component? What are these two files and two folders? What this will do? See, this chart is basically whatever the name that you give here, it will create in terms of folder. Inside this folder, these four are default. Okay, so values.yml and the chart.yml. Okay, so let's do cat values.yml. Okay, this contain all the YAML configuration in your workspace. Okay, see, this contains default values for prod. Prod is your helm chart. Prod is your helm chart to create your environment. So through this file will be having all our pod configuration. See, our image, it is pulling here, and it pulls an image from the repository where you stored, and it authenticates your docker image, and here it creates your pod labels, and here it creates your pod security context, and after the pod it creates the service here, right? Services, and also after the service it creates the ingress here. You're able to see this. All the services we can achieve through the single component, single chart called helm chart. Okay, similarly we also have where you see your resources here, right? We can define our resources for a particular pod, kind of cpu of 100 MB, of the memory 128 MB, and the request should come within 100 to 128 MB. Okay, and also we do have the liveness probe and the readiness probe that we configured here. This is the default template which is created by the helm charts by running this in the values.yml. Also we do have auto scaling here, correct? So the end enabled is false, and the minimum replicas of 1 and the maximum replicas of 100. So as soon as the demand increases, it increases to till 100. As soon as the demand decreases, it decreases to the minimum replicas of pod to 1. You getting it? And also we do have node selector and the tolerations and then affinity. So these are all the parameters that we use in the simple file called values.yml here. Through this values, it will create all our service pods, ingress, our liveness probes, our auto scaling, everything is handled by this single file. So we have to, the simple thing that we need to write, suppose if you want to have the replica count of 2, it will create 2 pods, and which image that it pulls, you have to specify your Docker image here from the repository, and you need to provide the tag here. Similarly, we do have also, when we want to use the multiple images, we can also define it here. And you will have to point your service account if you are using here. Through that service account, it authenticates to Docker image and creates the complete all the services of your ingress, your service, and a pod will create here pod label. So if you pointed any label, you can point it here. And also you will be defining the resources in the sense our CPU and the memory, and the liveness and readiness probe will be defined here, right? Liveness and readiness probe and an auto scaling, the complete package which is handled by the Helm through this file. Clear with this, which is values.yml.
So,
Okay, so we define this values.yml in that particular file, and after creating, just we need to run the command called helm install. So what is our the helm chart name? Prod, right? Prod. This is the release name and the chart name. Release name is also the same, should be same, and the chart name should also the same, right? So if I run this, so now currently it is not giving the response. Why? Because we have not added any values in the values.yml. It is not able to create any service, any deployment, any ingress, anything from the values.yml. You need to specify the particular component or particular specific configuration inside the values.yml. Then if you can run this, you will be created with a helm, with a chart name called prod. You're able to understand this? So I'll give the command here after. Okay, I'll give helm. So we do have some set of commands in the helm charts. Helm create. So I'll give with a generic way with the helm name. Okay, similarly we do have helm, what I ran here, helm install. Okay, so helm install, the first name which is release name and the chart name. Okay, and also after installing, you will have to, you can list the helm. Helm list is used to list the helm. Okay, list the helm charts. Okay, this is used to create an helm, create an helm. Okay, and this is used to install the helm, install the helm. Okay, so and also after installing, we should be uninstalled, that is helm uninstall followed by the release name, followed by the release name used to uninstall the helm. Okay, there are a lot of commands in helm. Okay, and also if you want to know the history, we will be having helm history followed by the release name. Okay, so used to check the history of helm. Okay, so these are all the commands that we're gonna use in the helm charts to play around in helm. Okay, see, through this helm configuration, we can achieve complete package. We can achieve our cluster creation, pod creation, deployment, ingress, your auto scaling, liveness and readiness probes will be achieved through this simple package manager. That's why we call it as package manager in Kubernetes. Okay, let's create some of the applications and some of the pod deployment and liveness and readiness probe in one of the project, and we will pick the code from the GitHub or maybe anywhere from the external repository, and we will try to create it. Great. Clear? And if you can also have the data or the repository, you guys can create the Helm chart and you can point the necessary values under values.yml, and I'll explain rest of the three what this chart.yml and what is this chart and templates. I'll explain in further sessions. Okay, clear with this?
Yeah.
You guys are with me, or
Yes, sir.
what is happening
Yes,
here?
Clear.
Okay, so I'll explain these three things in the further session. You can also point your values.yml if you have the values, and you can refer some of the document and try to install Helm. And if you can list Helm, you should be able to see the Helm chart that you created. And after installing, you can uninstall it. You can go for the other configuration. And if you can run Helm history, you will be able to see the history of the Helm that you created. Clear? Try to install Helm, try to create the pod, refer the document, and try to create the Helm chart. Clear?
Yes, sir.
Okay. So let's close the session. Let's connect tomorrow same time. Guys, please join on time at 7 o'clock. Okay. So let's connect tomorrow same time. Any questions and any doubts? Guys, I need to disconnect. If you have a questions, you can ask me. Else we'll connect tomorrow. Tomorrow same time. I'll not ping in group. Everyone should join on time. 7 a.m.
Okay, sir. Thank you.
okay, sir.
Anybody has any questions again? Okay, if no questions, let's disconnect. You guys are able to see my screen, right? I was sharing the screen. The screen is visible, right?
Yes, sir.
Yes, yes.
Okay. Okay, fine. Then I'll share this in the group. You can explore more in Helm, and also we will explore how do we create all the resources, and you can also explore on that. Okay. And here in the Helm, we have a lot of commands. Okay. Based on your requirement, you can use the commands. Okay. So let's close the session. Let's connect tomorrow same time. I'll stop sharing my screen. Where is the stop presenting? Okay, fine then. Let's connect tomorrow. Thank you. Bye bye.
Thank you, sir.